will be better next time I try. And even if I still can't do it yet, you know that I'm gonna stick to it. Yes! It's all about going through it, and I'm gonna tell you why. Whoopsie! Whoopsies, I made a mistake and it's okay. It's okay! Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay! Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay! Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too long, wake up, my love. Please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard, before long, before it's too dark. Wake up, my love. Please don't give up on me.
What is up? What is up, you guys? We are back at it again. Another day for some knowledge, alright? Let us get to this, shall we? Another day of 100 Days of Rootkit. If you are coming back, well, hello. It's nice to have you back. If you are new, well, hello. It's nice to see you. Let us learn some new stuff today. Now, if you did not know, we are a non-profit organization here in the US of A. If you go over to our website, you can learn more about us. But better yet, if you go over to the blog section, you can see we're actually doing giveaways every single week of 100 Days of Rootkit. Turn on the music here. Every single week. Right now, we're going to give away all of the stickers we have. You have 1 day left. I think it's actually like, because it has a 24-hour countdown, so I think it's like a day and then some hours. But it's just basic tasks like subscribing to our channel, following our Twitch, etc., etc. Nothing major, and you can potentially win. If you like what we're doing and you want to help financially support us, it's all tax deductible. You can go over to this awesome link here, which I will paste in the chat. And this weekend, maybe, we'll see. This weekend, maybe I'll go through all of the streams and update the links to be correct for all of those who are watching afterwards or not live. But all donations are being matched 1-for-1 by anonymous donor up to 10K. We have various goals here to meet, like 6K will be streaming for 24 hours straight, 10K shaving my head, and the notorious 20K, which we definitely don't want to get to. No one wants to see me without a beard, alright? Now, depending on how much you donate, you can unlock various rewards, like our stickers, the exclusive 100 Days of Rootkit stickers, this awesome collab t-shirt. Look at this. Look how epic this shirt is, alright? And then we have our sweater, which you guys have seen me wear plenty of times before, but I wanted to switch it up today. I wanted to wear the shirt because I really like the shirt. All right, sweet, sweet, sweet. Now, if you want to follow along with what we're doing, we have open sourced everything you need to know in order to get our cert. If you go over to our GitHub, you'll see pinned is our CompSci cert roadmap. This is what we're following. It's set up to be easy for you to look at everything in a bullet point list fashion and Google them and then learn about them in order for you to then pass our exam. Upon the launch of Project 26, which will happen, it's planned for the end of the quarter, we'll start slowly rolling out our content on there, and this will be a lot of our book content that you guys can then learn yourself. It will be way more robust and better than the bullet point list, because we want the information to be free, but to actually show that you meet the bar, that will cost, all right? Now, if there are no questions, I think we shall continue with today. Again, feel free to ask questions. I am over in the events chat, voice chat over on the Discord. So if any of you guys are Patreon or premium Discord members in our Discord, you'll be able to just jump in there and you can ask questions anytime you feel like it. If you are not, then you can just put it into the chat and I'll answer them as they come in. Sweet. So yesterday we talked a lot about the basics of operating systems and how they're utilized. A lot of things may not make as much sense to you guys initially. That's okay. It will make more and more sense as we move forward because some of the concepts are they're related to more business oriented environments where you have massive servers, you're running distributed loads across the whole entire network. It's big stuff, things that the normal user isn't too used to. So as we go through, we'll be referring to a lot of these concepts to help enforce them, all right? So don't worry too much. We will definitely try our best to enforce them. So let us move forward. Now, on the week that Taylor was teaching on hardware, you guys talked about a lot of the hardware that we're going to be mentioning right now. Most of it is pretty much going to be the motherboard. So as a refresher, your motherboard is going to be the big chip in that basically glues your computer together. It has a bunch of wires and connections throughout it that allow all the pieces to be connected up. All right, you can see, let me see if I can open this up, make it bigger. Right here, this little square area is going to be where your CPU lives. The slots above and below it are going to be for your RAM. Below that are PCI slots, which are for any types of additional items you want, like graphics cards, extra storage, media encoders, etc. And there's usually some basic I/O that's on there, like all of these USB, your Ethernet, and potentially other little pins down here at the bottom, which could be, for example, your power button and the power status lights and other various lights and doodads that you have on your motherboard. Maybe you have RGB. There's going to be slots in here for you to connect your RGB cables too. Hey, well, not a very well-known fact, RGB will increase the speed of your computer by 10,000%. Yeah, it's pretty cool. RGB tech is as revolutionary as blinker fluid, so you should definitely invest. That's all I gotta say about that. So something that comes pre-built into your motherboard is this concept called the BIOS. All right, and it's what starts the boot process of your computer. Because when I don't know if any of you guys have tried this, but you can. If you power on your computer with no operating system, no hard drive or anything installed, it will still boot up. And depending on what you have, it will also display a graphical interface that you'll see. All of you guys have this thing called a BIOS. That's what usually loads up. Well, not usually, it will always load up first. Now, the BIOS stands for Basic Input Output System. It's a very lightweight piece of software that's loaded onto your motherboard, and its job is to help with the whole boot process and initially like waking up your operating system and telling it what it has. Kind of think of it as like your operating system is the big CEO of a company, and he's just busy all the time, or she's busy all the time, dictating, telling people what to do. And when they go to sleep at night, you know, they're just passed out. They don't want to wake up at all. So they have a butler or secretary or something that will wake up earlier, schedule out their day, or figure out what they need to do initially, and then come in and like wake them up and be like, hey, wake up. Also, here's all the things you need to know for today. That's what your BIOS will essentially be doing. All right. So the BIOS system is a little outdated. So now we have this thing called UEFI. UEFI is like the new version, but it is also called BIOS typically. Let me see. Because again, you'll see a bunch of things as we move forward that it's usually always referred to as its older counterpart. So you'll see it also as EFI BIOS or UEFI BIOS. They'll kind of put the names together. Basically, the UEFI BIOS will have additional information, better graphics, and allow you to do more things. So for example, Windows 11 requires for your motherboard to be able to do encryption, and so that would be handled through your BIOS settings, and that's a functionality that you'll find in your UEFI. So it's just it usually is paired with pretty graphics. So BIOSes for the older ones you'll usually see are more terminal like. These ones are going to be pretty pictures. All right, so when your computer, we're going to jump around here a little bit. When your computer first starts up, when your motherboard first starts, all right, this I'm talking about very, very first start. Power was off completely and you press the power button. Nothing knows anything at that point. It's just a motherboard who is going to go through their boot process via their BIOS, and they're going to take a bunch of steps because it doesn't really have much of a concept of memory. They do have memory in the sense that they'll know what was last plugged into the computer, but it's not very big, it's not very robust. If your computer is off, if you switch out hardware parts, maybe add more RAM, add a GPU, take away a GPU, put in a new CPU, add some more drives, maybe a new SSD that you got. None of that is tracked because it's completely off. When your computer starts turning on, that's when it will reanalyze and go through a whole process called the cold boot. All right, cold boot is from when your computer is completely off. When you're starting from a cold boot, it will kick off certain processes to start rediscovering everything that's on your computer. One of those would be your post, all right, your post test. And if you've dealt with your own motherboard, you might know some of these. So let's go ahead and look at this. So, not this terrible site again. So the post, so power on self-test, is a process performed by firmware or software routines immediately after a computer or digital electronic device is powered on. So post will typically only happen after a cold boot. What it does is it effectively looks around and sees what is currently connected to the device, and it makes a nice list, and then it will know what's currently connected and will forward that information off to your BIOS to then potentially forward it off to your operating system, because it needs to feel around and see what's actually attached. So it's very, very important that you that your computer is completely powered off. All right, please don't connect things while your computer is on, but it should be completely powered off in order for this to happen. A warm boot happens when you do a reset on your computer. It won't actually go through the post test. It will be a quick reboot where it just turns off the operating system and then starts turning back on the operating system. It doesn't do all of the steps to do a startup like a cold boot does. So if you are connecting new hardware, please make sure it's off. But also, if you are crazy and you plugged it in while it was on, this is why you won't see it show up sometimes, because it didn't go through the post and discover it and then report it on forward. All right, so after you do this test, this post test, your computer might discover some hard drives. All right, and when it discovers the hard drives, if there are multiple of them, it will assume whatever is plugged in slot 1. They are labeled 1 through however many you are, or how many ever you have. And that is the priority they have in regards to what boots up first. Now, you can change this in your motherboard settings on if you have a drive connected to maybe slot 3 and that's the new operating system you want it to run. You can change it so it will boot up on slot 3, but by default it will go into or boot up on slot 1. Now, hard drives, whether they're a SSD or a magnetic disk, they're completely blank. They're like blank canvases, all right? A blank canvas has absolutely nothing on it. So when you plug in a hard drive, and even if there's an operating system on it, you need something that tells your motherboard how to start that operating system, because it's just ambiguous like data at the end of the day. Your motherboard isn't smart. It's very basic. Its only job is to make sure that it itself is running, discovers things, and then forwards on that information. But your hard drive is blank at first. So when you first create a new drive for an operating system, you'll usually have to attach a master boot record to it. It's a very small piece of software that goes on the hard drive in order to tell the motherboard like what to do next. So if we look here, it's going to be a special type of boot sector at the very beginning of a partitioned computer's mass storage device. So very beginning of your hard drive. And it's very small. Here we go. Approaches to slightly raise the limit. No, that's not it. Where's the size of it? The size should be on here somewhere. It's very small. It's like 100 something bytes. If you guys see it and I'm not, then you can go and make fun of me in the comments. But it's like 100. I think it's should I even say like 180 bytes, 196? I don't know. It's a very small piece of software, and all it does is it tells your your motherboard where to go to next, because your motherboard's job is just to maintain the motherboard and then pass off responsibility to something else. All right. Are there any useful pictures here? Will this one say the size? Not quite sure. All right, we're gonna move on. What does this say? This is not too bad. We'll maybe come back to this picture. All right, and then there's a different type of initial like little program that can be at the beginning of your drive. You can have a master boot record, which is typically for drives you want to boot into. All right, it's a little program to help those drives boot. But if your drive is not going to be used for an operating system that is going to boot up, you don't need that. It's just going to be for storage. So instead, you can just make partition it with GUID or GPT. All right, it's a big name for the entire thing. It's usually referred to as GPT. And let's see what, not this, let's see what Wikipedia says. And we have an actual practical example for you guys to go through and see here in a second. Blah, blah, blah. This is not what I want. Where is it? Let me just copy this whole thing. Here we go. Your GUID partition table. I don't really say this much. I don't know how people go about pronouncing it or what the agreed upon term is. Wikipedia thinks it's just GPT, so we're just going to call it GPT. But it's the standard is a standard for the layout of partition tables on a physical computer storage device, such as a hard disk or solid state drive. All right, it's just how the disk that you're about to be used is layout, how you want the information laid out on it. So let's dive into this a little bit more. Some actual examples will be very useful to kind of see this. So on your computer, if you type in hardware, is it? There will be something called Device Manager. You could just type in, do we want Device Manager? No, hold on. What is it called? Can I just do, yeah, let's type in hard drive. So something will come up called create and format hard disk. Oh, is this part of disk management? We'll wait for this to start up. It can kind of take a second or two. And we can see this stuff in action live. Come on. I believe in you. There we go. I have a lot of drives connected to my computer. Let me see if we can zoom in on this at all. I'm gonna guess no. So hopefully this isn't too hard for you guys to see. But we have drives here and we have a bunch of stuff going on. So let's talk about this and let's talk about the concepts we just learned about, particularly master boot record, the GPT, and we're going to be throwing this word called partition around. So partition is basically segmenting your drive. So think of it like if you need to store a bunch of files in a filing cabinet, or if you store your files in a box, you could just throw them all in there and use it, and that would be just fine. That might be perfectly fine for most of your use cases. But there may be scenarios where you want to put dividers between each set of files to keep them more logically separated. That's what a partition is, all right? It's pretty much the same usage when you talk about partitions in the real world. Hard drives also use partitions in the same way. You can take a hard drive and you can partition it and basically segment it out into multiple bits. And each one of those you can actually connect to your computer and have them like logically separated out. Now, by default, your operating system will do this. So if we look right here, I believe, is this was my old operating system. You'll see there are 3 different partitions on here. One is the main one, which is 463 gigs. There's a second section here marked as the recovery partition. So if you ever have to recover your operating system or various other operations, this may be used. And then there's the initial 1 gig, which I can't remember what this part is for exactly. I want to say for updates or when your computer is going through updates, but don't quote me on that. This will not be on the test. The main point is for there's 3 different partitions on this exact same drive. And it's up to you when you plug in a new hard drive, or if you have hard drives currently installed, you can partition them. Now, if you want to repartition it after the fact, like after you've used it and put data on it, usually you'll have to format the entire drive before you can repartition it. So you have to kind of know beforehand what you want to do, because even though you may think of your drive like it should be filling up from the very beginning to the very end, that's not actually what happens. Things are sometimes stored randomly throughout it. I know it's kind of weird when we talk about storage. There's a lot of weird stuff going on here, which we're gonna really break it down here. If you were to right click on one of these, you'll be able to see that you have an option, at least on some of them, to convert to master boot record, which is MBR, or convert to GPT. All right. This is what we were talking about. This is the little bit of logic that goes at the very beginning. Does it have more information here? Goes at the very beginning of your, here we go. So you can see right here, this partition style is master boot record. So this goes at the very beginning of your drive, and it will dictate, if that drive is going to boot or is capable of booting or not. You can do this to a storage drive. You can give a storage drive an MBR. That's a-okay. It doesn't mean that that drive might particularly be booting up. It can still be used for storage. Any questions on any of this so far? Now, when you do partition something, let me see if I can. So this one does. Oh no. Hopefully that drive. Oh, there we go. So this lets me shrink the drive after the fact, so I could add a new volume if I wanted to. Trying to look for something in particular here. Well, I don't think it's on our topics to hit on, so I won't. I'll just bypass it for now. You'll also see this thing called file system, and this is the layout of your data and how it's stored, particularly the metadata of your data. Drives are actually, files that are stored on drives are actually more like a book, where at the very beginning of your book you have the chapters that are laid out, and it tells you what page everything is on, and then you can go to that page to see the contents or see the actual data. So just because, so it's typical in your operating system, so when you actually delete stuff, you don't actually delete it most of the time. It's actually just deleting the chapter at the beginning that's pointing to that data. All right, so that's why things like forensics, data recovery can be done on a computer, because when your computer deletes stuff, same thing on your phone and so forth, it doesn't actually delete it. It just deletes the bookmark to, or the chapter that references to that area in your disk. And when it does that, the data will then potentially be overwritten. This is something important to know as we move forward with software development, if Taylor didn't already hit on that, because this can potentially add vulnerabilities to your program, but also it's a security breach, because if you throw away a hard drive that you just deleted the files off of, or you performed a quick format and you sold it to someone else, they can potentially recover everything that was on there and see all of your data. You want to wipe your drives fully. There's applications, I think in the format options here, there is an option for a full format. I'm not going to click on them because I'm not going to test my luck today. But you want to do full formats. And even if you just do a full format, it's not guaranteed that all that data will be completely wiped. Sometimes it can have a shadow left behind of what the data was, and it can still be recovered. So it's recommended that you wipe your drives multiple times, or format them multiple different times, and then destroy them afterwards and then throw them away. All right? Do not resell your hard drives. That is a big no-no. Do not do it, because you could potentially have a lot of personal information stolen. Let's see here. So we talked about these, talked about cold boot, warm boot. What should I do with them? Like I just said, with your hard drives, you're going to want to completely format them after you're done with them, and then destroy them before throwing them away. That's the recommended way to get rid of them, because there is personal information on them. So if someone is collecting them or picking them up after the fact and they're malicious, they can potentially take data from you. There's lots of people that make a living being a black hat hacker by buying up pallets of used hard drives, plugging them in, and trying to recover personal data from them. All right, let's see here. Volume boot sector. So the volume boot sector is also known as volume boot sector, volume boot record sector, partition boot record, partition boot sector. It's a type of boot sector introduced by IBM. It's found in personal storage devices such as a hard disk, or unpartitioned device such as a floppy disk, and contains machine code for bootstrapping programs, usually but not necessarily the operating system, stored on other parts of the device. So code in the volume boot record is invoked either directly by the machine's firmware or indirectly by code in the master boot record or boot manager. Code in the MBR and the VBR is in essence loaded the same way. So the VBR, invoking a VBR via boot manager is known as chain loading. Some dual booted systems, such as NTLDR for the bootloader by Microsoft, takes copies of the bootstrap code that individuals copies of the Bootstrap code that individual operating system installs on blah, blah. Okay, let us move on. It's a pre-built piece of software, typically from the manufacturer that's going to be on your device. Let's see here. Is there a better... And it functions pretty similar to your master boot record, if I'm recalling correctly. Let me pull it up on my notes here real quick to make sure I'm not missing something, because I feel like I am. Oh no, something went wrong. If you guys have any questions, please go ahead and ask them. We got some comments and questions earlier in the Discord. I think you guys have all pretty much agreed, especially here in the chat, that keeping the classes to 1 to maybe 2 hours at most is going to be most beneficial for everyone. So I think that's what we're going to try to do moving forward. Let's see here. Any removable device is not found by searches to computers, hard drives. Okay. So it says here in my notes that your BIOS typically will look for a volume boot sector first on any removable drives, all right, before moving on to the master boot record. So you can install like things like an operating system and so forth on things like thumb drives that are plugged into your computer, and then have that install an operating system onto a hard drive with a master boot record that is then used after the fact to load up everything. Okay, so the master boot record is going to have 512 bytes of potential information it can have, and it's going to do a lot of fancy stuff to start up your computer. Particularly, it's going to, what do you call it? It's going to tell your computer what type of endianness it has, which is the way data is laid out on your computer or stored on your guys' computer. We have talked about this before, and definitely should have been hit on by Taylor. Again, this is endianness, like with an E. Endian. Did I spell that right? Not that one. Computer. Is it just an E? There we go. Like this. Basically, whether you're, think of it in hex. This is a perfect example. Whether your hex values, quote unquote, are going to be stored as if you would read it normally in most countries, or if it was in more of a backwards sense. So if you look here, there's big and little, and you can see in memory where it's stored, it can be stored in two different ways. Let us see here. I think that's about good. I can't really show you guys the BIOS or a lot of this stuff because it requires me turning off my computer, which then would stop the stream. So you're free to experiment at home. All of you guys have these. When you turn on your computer, you'll see a quick screen that flashes up for maybe a second or two, or maybe some text at the bottom that will usually say, if you press the delete key, it will let you enter your BIOS. All computers have this. All computers will say this. So if you smash your delete key, that it's usually the delete key, then it will load up your BIOS, and then you can go play around and see what's in there and a lot of these systems. All right, in there also, you'll typically have the option to do things called over and underclocking. What does this mean? So by default, your hardware, whether it's the CPU, your RAM, your GPU, I'm pretty sure, yeah, even your solid state drives, are going to have the ability to over and underclock them. What does that mean? There's clocks on your devices, not like clocks like you think normally, but there are usually quartz crystals or something along that sense to tell time, because time runs everything at the computer hardware level, and that's pretty much how you get your cycles that are in your computer. And each one of those cycles is an action that can be performed. Now, by default, all hardware you buy will have a default clock that it will be at. It's called the base clock. Now, manufacturers are smart and they have it so a lot of these can go up in clock speed, aka they can get faster, but when they do, they get very hot, so it's usually for bursts. But if you are really into hardware and you want your hardware to be more performant or faster, your BIOS will have options for you to potentially change the clock speed of your hardware. So this is usually balancing the power that you send it with various other programmable items. I'm not a overclocking expert, but this will help you basically squeeze out more and more performance and raise the base clock of your CPU or your GPU or your RAM to something that you would want instead that's more performant. Again, it will generate a lot more heat, so you need to dissipate that heat. It's not advised for you to do it unless you are able to dissipate that heat. Also, it's not advised because it will chew through and destroy your hardware faster, because again, electricity is pulsing and burning through your hardware all the time. Computer chips will not last forever. They will eventually die, and that's because electricity is going through it and altering the state of everything slowly and over time. So if you up the voltage on your chips, it will degrade your chips faster, and so overclocking is great, but you'll see performance drop and the life of your chips drop. If you want to keep things conserved for longer, and you want to save on power, and maybe you don't have the best cooling, or it's really, really hot and you have terrible AC, you may want to do underclocking, which is very, very common in mobile devices. Things will be underclocked, which means the opposite of overclocking. They'll be slowed down, less power will go to it. Things like the Nintendo Switch are usually overclocked when you don't have them in a docked mode, underclocked when you don't have them in a docked mode, because they'll get really hot and the fan on it is kind of weak, so you'll get less performance. So this is important things. Again, I'm not too big in the scene. I know for a fact your motherboard is where you need to go to handle most of these settings, but there are some software there are some pieces of software that are available specifically by Intel that can let you do this in your operating system. But to get more information on this stuff, definitely go over to the YouTube channel for Linus Tech Tips. They have lots of videos about the whole boot process in general, but a lot of these individual pieces that you can go check out. Now, when your computer first boots up, there is no operating system, there is no control, there is no concept of user and ownership and anything. There's just data, all right? There's just data that's all around. It makes absolutely no sense to anything, and order must be given. That's what the master boot record is for. But also, after your master boot record kicks off, things are still being stood up. Things are still very wild. So during this process, in the master boot record and post master boot record, that's where you would find boot kits installed. So if you remember back, we talked about rootkits and bootkits. Boot kits are going to be pieces of software that are meant to be deeply embedded in your disk to change functionality, and they're pretty much impossible to find. So this is where you would be infecting it if you had a boot kit piece of software. Mostly because you get an advantage of this thing called real mode. Real mode is 100% unadulterated control of everything. Because at this step, there is no concept of an operating system. Things are not stood up completely. So you are very, very vulnerable to attacks at this state. So during real mode, you can get unadulterated access to all of the memory that's available, the operating system, pretty much anything that's there you can alter and manipulate. It's no bueno. So your operating system will try as quick as possible and as efficiently as possible to get to protected mode. All right. Protected mode is when your operating system is now in control of your RAM, GPU, CPU, so forth, and they won't let certain things happen. All right, unless you have permissions, because that concept will now start being introduced. So it's very important to know these concepts, because if you are going into the cybersecurity field, this is important to know, or you want to work at Microsoft or Apple or whoever else is making operating systems. This is an important concept to know. And during real mode is when you're most vulnerable to everything. Any questions on that? Let's see here. Let me see if real mode, let's see if there's, I know there has to be some good pictures here for us to look at. Why are these so terrible? Versus protected mode. These are terrible pictures. All right, any questions so far? How are you guys feeling so far? No, I'm gonna stop looking for these pictures because they are no bueno. So again, BIOS and UEFI, this is going to be what's preloaded on your motherboard, all right, from the manufacturer. This is going to be first doing a lot of discovery and setup of your computer before your operating system even starts. After that, there's two different ways for you to read data off of disk. There's just lightweight programs that you can potentially put on them that will then help you move forward with understanding that data, because again, everything is very arbitrary. There's two different types of boot processes. Cold is from a complete stop and you are starting up, and only during the cold process will you go through post, which will reanalyze everything on your computer and see what even exists and then forward that information on. Warm boot will not do that. So if you do a reset, that will not start your post. All right. Volume boot sector is going to be for identifying devices that are plugged in that you want to boot off of, typically USB drives, and they are used sometimes in conjunction with master boot records. Overclocking and underclocking are going to be increasing or decreasing the compute speed of your hardware. It could be anything for that hardware, as long as it has a clock speed, which all your hardware does to a certain extent. So RAM, GPU, CPU, even your solid state drive. Real mode and protected mode. This is when your computer first starts up, all right, is real mode. So starting with when you first press that on button all the way up until your operating system starts to load in, but it's only to a certain extent. Once that extent is met where you can get protections and concepts like roles and permissions loaded in, then you're going to be in protected mode where your operating system can then take it from there. It's in a stable enough state. It's basically like a child growing up. When they're young, they're very exposed and malleable, and then as they get older, they know better, they're wiser. And during these steps, this is where you can be most exploited during a boot kit, and then root kits will usually take off in protected mode. That's the quick review. Any questions there? If not, we'll take a 3 to 5 minute break, and then we're going to get into Windows. We probably will not complete Windows. Depends on how you guys feel. So during this break, let me know how you guys feel. We'll plan on maybe doing like half of this, and then I'll ask you again how you guys feel. If you guys are good, then we can just finish up Windows, but we definitely will not go further than that today. All right, so I'll see you guys in 3 to 5 minutes. Yeah. Thank you.
Do you need anything else?
No, I'm all right. Thank you.
Your mic is still on.
All right. We are back at it again. All right. So, before continuing, quick recap. Rootkit, nonprofit here in the US. If you donate to us, it's tax deductible. All right. Use this as your tax haven, please. All right. We need moolah. Doing things for free is not cheap. All right. So please help support us. We do giveaways. We're doing a giveaway right now. Every single week of 100 Days of Rootkit, we are doing a giveaway. This week is week 4, and we're giving away all the stickers. Lots of amazing stickers that we have. You can see them all on our merch site. These are the 100 Days of Rootkit exclusive stickers. They will only be available during the 100 Days of Rootkit event. Now, if you like those and you don't end up winning, that's okay. You can still purchase them if you go over to this link, which I will go ahead and re-put into the chats. And you can donate here to us directly. And depending on how much you donate, you'll get various different rewards that you get to choose, like the stickers, our awesome sweater, which I highly recommend, and this cool, amazing shirt. Look at this. Hold on. See what it says right there? The next biggest thing, all right? Now, depending on how far we go or how many donations we get, we have big pillar events like teaching for 24 hours straight, which may be useful for when we get into the programming section. The shaving my head, which, all right. And the one we will definitely not get to is shaving my beard. No one wants that, all right? All donations are being met one for one for the first 10,000. All right. Let us continue. So just, again, for the boot process, don't get too caught up on these concepts. Just know them at a general overview. We're not going too deeply into the hardware or the whole process of all of the hardware. If you are interested in that, you can definitely take deeper dives at your leisure. Let's move on to Windows. The Windows operating system, most common operating system out there for computer hardware. I think technically mobile operating systems are the most common one now. Put an asterisk behind that, all right? We brought up the stats yesterday, but I don't remember them. All right. So in your Windows computer, when you do a clean install of the Windows operating system, there are going to be 2 accounts that are built in. These are your built-in accounts. These exist no matter what when you first install a Windows operating system. This is going to be the admin account, or the full name of it is administrator, and the guest account. So I just did a clean install, and if we can look in here, you'll see that you most likely will have this also, a folder called public. This is for a user, that's the guest account. It is recommended that you disable this if it's not already disabled. I'm not a big hardcore Windows person, all right? So ask your nearest Windows SME on whether it's auto disabled or not. Local accounts are going to be the ones you make after the fact. So my account on this computer is going to be a local account. If I make more accounts on here, those will all be local accounts. Typically, your normal laptops at home and so forth are all going to be local accounts. They are accounts that are made and stored locally on that device. There's one final type of account for Windows. Those are going to be domain accounts. This is controlled by a domain controller. What is that? If you've worked at a bigger business, a school, any type of bigger organization, and you can go and hop computer to computer and log on to that computer and your account will be loaded up. That's because it's a domain account. It is stored and belongs on a central server called a domain controller, and that will basically issue out your account wherever you log into. It's not actually stored on the local device. We just talked about the 2 built-in, admin and guest. Guest will have pretty much very limited perms. They can't do too much on the device at all. Admin, though, this is an account you want to keep super secure. This gives people access to everything on your computer. They can do just about anything they want to do on the administrator account. This is more true on Linux than it is on Windows, because there are still some things that an administrator can't just do, but not very good for someone to have. SAM, so Security Account Manager. This is if you have a local account. This is what's going to be storing your password and like user password information. Not quite sure how true that is now with Windows 11, but because there's the whole like login, make a Microsoft account crap. But SAM is still used for local storage. If you want to get someone's credentials off of their computer and try to hack their passwords, this is what you would need to look for on a Windows computer. All right, you're going to need to look for this and then grab the information from it, and then you can go about hacking and breaking their computers. On earlier versions of Windows, this was pretty accessible, and your password was not encrypted very well or stored really well. I think it was just hashed, and it was super easy to decrypt because the password that you were given or that you gave was actually not even what was all used. Hold on, let me see if the okay, so SAM is used even in 11 for your password storage. This is where you can find it. This is where you can see potentially your passwords and see the hashed version. So all passwords are going to be hashed, which is a way of storing data. It's a one-way function. We've talked about hashing a couple times. This is technically blockchain technology. So if Microsoft wanted to, they could boast that they're using blockchain technology, even though blockchain tech was built off of this. Hashing is also part of the cryptography space, so you'll see them referred to as cryptological functions. All right, they're just fancy different ways of saying a hash function. Demonstrated. There we go. In 2012, it was demonstrated that every possible 8-character password, NTLM password hash, so this was the older Windows operating system, could be cracked in 6 hours. In 2019, this was roughly 2.5 using modern hardware. So there's been a lot of insecurities in previous versions of Windows in regards to their operating system and password storage. So it's no bueno if someone gets that from you. How it is in its current state, I'm not quite sure, but you definitely want to make sure you're using the latest and greatest operating system, because starting really, it kind of started with Vista and 7, but it really took off after Vista and 7. Microsoft started pouring billions of dollars into security on their platform. So everything really from 8.1 and up has pretty good security measures in general compared to how things were prior. So make sure you're using the latest and greatest. Windows just announced that I think in 3 years from like last week or something, they'll be dropping support for Windows 10. So if you haven't already, you're going to want to make the migration to Windows 11, because in 3 years-ish from now, you will no longer get any new updates on Windows 10. No bueno. No bueno at all. All right, so let us go back here. So domain controller is going to be, I guess it's paired with Active Directory. So your domain controller is going to be a server that is responsible for authentication, all right, on your on the network. So this is typically with Windows, because Windows created the whole domain controller and Active Directory. Let's see here. I think, yeah, there's other services like LDAP, which we've talked about before, which is I believe it's the open source version. What does it say right here? Yeah, it's the open source version, which is what most Linux distributions will use instead. So if your company has Linux and they use that, most likely they'll have an LDAP server. It's more and more common to see that organizations in general will just have LDAP since it is compatible, I believe, with Windows and the Linux counterpart. Let us move on. So domain controller is what you'll be authenticating against when you log into your computer. Active Directory is going to be for management, right? There's a directory service. Active Directory is for your centralized domain management. So after you're authenticated through the domain controller, so you're logged in, Active Directory will kick in next, and this is what will dictate what you are able to do and what you're not able to do. Typically, Active Directory and the domain controller will be on the same box. Any questions so far? Let's move on to security groups. Taylor. Oh, there you are.
Hey,
Oh, sweet. That you came in quick. Were you just sitting there?
yeah, I've been here for a little bit.
Okay, perfect. Security groups. Do you want to talk about security groups?
So I can, but I'd like to back up.
Okay, go ahead.
A little
Back
bit.
up. Back up. Taylor's
Alright,
more of a
so-
Windows guru than me.
So I just want to provide a little bit more context to why does Active Directory exist? Like, why do we care about people authenticating at the network level? And this solves a lot of the basic problems that we used to have, and we still have every day now. Where, let's say we have multiple computers at our office, and you want to be able to sign in at any one, because like Monday you want to work at the left aisle, but the Tuesday you want to work at the corner desk, and then Wednesday you want to work on the second floor. By authenticating at the network level, it allows you to have a roaming profile, which means that you can log into any of those computers any day of the week, as many times as you want. Now let's say also you have some other things like file shares. You want to share a picture, a funny cat picture with your coworker, so you toss it in a file share. You want everybody that's authenticated on that network to be able to access that file share. So that's how we do these in Windows environments is Active Directory. And every major operating system, such as Linux, stuff like that, they also have their counterparts to Active Directory to provide the exact same functionality, but using their protocols.
Solid. Solid. You want to talk about security groups?
I'll let you take that, but also I'll toss in some free chicken here as well. If you're hardening your network or you're looking for vulnerabilities, Active Directory is the key right there. If you pwn an Active Directory server or your Active Directory server gets pwned, they have access to all of your network resources. And if they get an admin, they can create more admins. They can remove your ability to administrate. So that's stuff that you got to protect right there.
Those are all extremely, extremely good points. Very good, very good. I give that a 10 out of 10. So let's move forward and talk about these next couple of items, which some of them are related to Active Directory, and then some of them are going to be for your local user. So security groups is, let's go over to the Microsoft site and zoom in a little bit here. So security groups used to assign permissions to a shared resource. All right. That's the big thing for them when you're on Active Directory. If you want to have a shared resource, you're going to use security groups and generate them to assign those permissions on those items. Then they can be, messed with by people on the work group. Let me see. Why are these definitions are not coming up very well. We're going to take a look at this in play on your computer because everyone by default will have a work group that you are a part of on your built-in accounts. And then is that true? Am I getting confused here? Pretty sure, right, Taylor? Well, let me pull up my notes here real quick.
Yeah, I sadly don't quite remember the difference between a work group member and a security group. and like what their exact functionality is.
Yeah, so your groups are going to be so security groups are just groups of people that you're logically like grouping together, like the accounting team, the HR team, the engineering team, and they will at a whole be able to access certain types of resources. And then moving on here to the work group. Where is it in my notes? Let me pull it up here. Remember, Windows.
So it's interesting. Over here, I have that an Active Directory workgroup is a peer-to-peer network with no central authentication. This means that each computer in a workgroup can function as both a client and a server.
That sounds, I believe that sounds about right. Workgroups are small peer-to-peer local area networks where each computer has its own set of rules and settings managed by the admin of that device and a unique computer name in that workgroup. So on your computer, what is, do you remember the command off the top of your head, Taylor, for the work group? It's basically a name for your computer, which is what it comes down to, is what it really comes down to. And then domain members are going to be people that are a part of the domain as a whole. Let me pull up here we go. Domain membership is the state of trusting a third party, the domain controller, for identity and authentication information. Any computer can be a part of the domain. This is for membership. Net login, I believe that was the command. No, net login is going to be for we're blanking on these a little bit right now, you guys, so we'll revisit it tomorrow. These, I believe, have been removed from the exam. I'll double check. I can't remember exactly right now, but let's go ahead and move forward to the next item here, which is going to be the file structure for Windows as a whole. So by default, when you install a new Windows operating system, it has a defined file structure, which you can look up on things like Wikipedia here or on your actual computer and see. All right. Also, if you did not know, let's go ahead and click on this. If you right click and in properties, I'm probably going to mess this one up too. There is an option in here somewhere. I cannot remember right now. But there's an option for you to be able to view hidden files, which is what you can see here on my computer, which are hidden files that are usually hidden. Maybe it's in view. That are usually, oh, there's a checkbox right here for hidden files. I highly recommend this. Highly recommend turning this on if you are developing, which you guys all are going to be developing, because a lot of the files that you guys need to be able to access may be hidden by default. So make sure you go ahead and dive into that and turn it on. So by default, your Windows will have a default folder structure, which will have the perflog folder, program files x86. The difference between these is one is going to be all 64-bit applications, and the other one is going to be backward support for 32-bit applications. All right, x86 I believe is the one for your 32-bit applications. I guess 16-bit also. Not quite sure if you ever even find a 16-bit program, but anything that's 32-bit is going to go in here, and everything that's 64-bit is going to appear at the program files level. And then you're going to have users. And users will always have two things in their default, which is going to be the, the public folder and then this default folder. And then you're going to host your operating system. So program files are going to be the programs that you want or that you install, Windows is going to be, sorry, users is going to be the users that you have. Windows is going to have your Windows files, and the perf logs is going to have logs that your computer generates. That is the default structure of your operating system. So if you ever need to find anything, those are what you're going to need to look into, and that's where you should be able to find various tasks. Now there's one last one in here that says app data. App data will typically be hidden. Here we go. It's going to be a part of every one of your user accounts. They're going to have app data. Inside of there are going to be several folders which store various information for the applications that you are running. So this is definitely an important place to be aware of that exists. So yeah, as you just saw on my computer, it will have 3 subfolders called roaming, local, and local low. So roaming is for your network logins for your like roaming profiles, and local low do not sync up to the network, which you'll see these are always going to be full of information on your local computer if you're not when you're for most individual users when you're not a part of like a Active Directory. Anything you want to add in, Taylor?
No, I think you covered it very well.
All right, so we just talked about users, folders, program files, windows, file directory, attributes, properties. So Windows uses discretionary access control lists, which we talked about a little bit at the beginning. There's 3 major types of access controls: discretionary, mandatory, and role-based. Role-based, I would say, is more commonly found in the developer world when you're making applications, but Windows uses discretionary. Now you can see the permissions that are, before I move forward, if you guys have questions, just feel free to ask them. So Windows uses discretionary access controls, and you can view this if you go to a file and you right click and click on your properties. Over in security, and this may be pretty small for you guys, you'll be able to see who has access to that data, all right? And you can click on them to see what permissions they have. You will always see read, write, and execute, but these extra items in here are specific to Windows. So the special perms, modify, and full control, and list, folders, contents are going to be unique to the Windows operating system. So this is your discretionary access control lists in effect right here, and you can go ahead and add new people, and then they'll have also access to that. You can add directly groups of individuals or individuals themselves to get access to the information. Anything you want to add in there, Taylor?
Overall, all of these systems are layered on top of one another. You shouldn't be using any one of these like as standalones. Like you can't handle all of your Windows security just by doing file permissions, and vice versa. So a lot of these tools are important to know, and the tie-in for being a developer and knowing how these permissions work is it's going to bite you in the butt one day. You're going to write this super awesome script and you're going to try and run it, and it's going to tell you it doesn't have execute permissions. So knowing like what that even means and how to go and see, does it have execute permissions? Are you the problem? Is it the group that's a problem? What's going on? It's really important to understand the fundamentals and how to find it and understand those issues. And so that's why we're going over it here.
Yeah, it's good for you to bring that point up, because if you are analyzing malware, or maybe you're making malware, or you're making something that's not malware, but you don't want just anyone to be able to run that software, you're going to want to lock it down. And this is where you can go in and lock down who can do what. So execute is probably one of the most important ones in here. So locking down execute when needed is definitely important. Let us move on to NTFS, New Technology File System. This is the file system that Windows utilizes. and only Windows utilizes this. All right, it's made by Microsoft, and it's just how they lay out their data. Because again, think of the data on disk as a book with chapters. You need to know how those chapters are laid out and how that data is then stored afterwards. If you try to plug in a NTFS drive into another computer that's not Windows, it may not be able to understand or read the data off the disk entirely. This is most commonly found if you try to plug in your Windows drives into a macOS computer. You'll usually have issues where it just won't read it at all, and you'll have to download and install some third-party software that will allow you to do it. Linux, there's in most distros, they have the ability to interface through third-party software and packages that are available. But you don't want to typically use this outside of the Windows world because you don't get any additional benefits. The big thing for NTFS is it has support for these for the discretionary access control. So if I pull up this again and we go to properties, it is formatting everything in particular to be able to support these extra permissions that you're able to assign items. When you don't do that, which most other drives will be FAT compliant, so file allocation tables, they'll use that instead. Those ones are typically more simplistic in what you can do, and you'll see in other operating systems like macOS and Linux, they are simplistic, more simplistic in the permissions and things you can assign onto files. Anything you want to add in there, Taylor?
No, you covered it very well.
Viewing and setting file permissions, we've pretty much already talked about that. If you go over to security, then you can view the permissions and you can set them. Let us move on to backups. So Windows is capable of performing several different types of backups, and it's up to you on how you want to go about it, and some may be more beneficial than not, especially if you're remotely backing up your computer. So if you're on a larger organization's network, doing there's 3 different types here. Doing one over the other may be more beneficial to you in the long run, particularly when it comes to storage, how much you are storing, and then speed. All right. So let me see if I got here we go. It should be right here. So your full backup is going to be the entire system itself is completely backed up. All right. The pros is you literally have a perfect copy of your system. The cons is you're backing up everything. So it's going to take quite a bit more time, and it's going to potentially utilize more storage depending on how many times you're running full backups throughout the months, day, or years that you are backing up your systems. After that, we have incremental, which will back up only specific files with specific archive attributes. So inside of here in your attributes, so it lists attributes right here on your folders and on your files. Now this right here says read only. You can also make items hidden. There are command line versions of all of these commands that you can do, but if you click on advanced, you'll get some more items on here. One of them is going to be ready for archiving. So if you want an incremental archive system, it will only archive specific things. So maybe you don't want to archive the whole entire operating system and all of the thousands of weird programs you installed. Maybe the only thing you care about is, I don't know, some work folders and then your folder of memes. All right, cat pictures. Then you can select certain types of files and mark them with the archive attribute, and those ones will be only archived. And if you ever turn off the archive attribute, then those will no longer be archived. The pros is it's going to be a lot quicker. All right, The only con is you aren't backing up everything, so when you do a restore of your computer, it may not restore things to the exact location they were in. You may have to manually like move around and reorganize your data. Anything you want to add in there, Taylor, before I talk about differential?
So I might be jumping the gun here a little bit, but knowing the different types of backups and when and why like companies and organizations would do them is important when you're going to decide what type of equipment you need if that's your role. Like how we talked about in the previous lecture with how we have like our tape drives. So like those are great for full backups when you want to toss that whole thing in storage and in case there's a hurricane you pull it back out. But those you have to know that like this is gonna take a lot of money, it's gonna take a lot of time. And so like there's different times that you want to use each of these different backup methodologies and when it's appropriate.
All right. Whereas okay, items remain on file backed up or different backup selected files with. So differential is going to be also backing up your files with the archive attributes set on them. The archive attribute remains on for files during the backup of differential. So, okay. System restore requires. So the difference between incremental and differential is that by default, incremental will go ahead and auto remove. Whoops. It will auto remove the archiving after it's already been archived and backed up. Differential will always keep them on and keep backing up them. Does it do versioning? I can't remember right now. Taylor, do you know?
I don't recall off the top of my head, but I don't think so.
We can look it up real quick. Why you gotta do this? So this does come into play most importantly, like how Taylor was kind of hinting on data archiving, and then of course your development environment when you deploy things, how you want things to be stored at any given point, being able to restore later on if maybe the power went out, things got corrupted, or there was potentially a hack that was taken. So let's see here for the can be illustrated as this. Okay, so incremental will be archiving the changes after every single day. So the above assumes that backups are done daily. Otherwise, the changes since entry must be modified to refer the last backup. So it will incrementally back things up since, for example, the previous day, incrementally updating and updating and updating everything. For differential, it's important to know, remember the industry standard meaning for the meaning of these two terms, because while the terms above are in very wide use, some writers have been known for reversing the meaning. For example, Oracle uses a backward description of the differential backups in their DB products as of May 14, 2015. So differential in differential level 1 backup, and this is okay. Why? I'm kind of confused now, Taylor. Help me out here. I mean, as you guys can see, Oracle can't even get on the same page. There's just fine differences between all of them, but I believe differential will literally keep entire, what do you call it? Entire new backups based off of any changes from a given date. So since Sunday, and it will happen every single day. There are lots of videos online explaining these, so definitely go check them up. But it's most relevant I wouldn't really say in regards to Windows, but more so when you are talking about your code bases and your databases. That's where I'm more familiar with them, and why they are included on the test is more so when it comes in regards to that. So let's see what this graphic says. Additions and alterations since the most recent full backup is differential, and then incremental is additions and alterations since the most recent incremental backup. So you can see on this graph how they go about adding their data. So incremental will be going through constantly and backing things up, and it will usually be on a set schedule. So you'll do things like if it's pre-built into the software or operating system, you'll set typically a time, or you'll make a cron job, and you'll specify, does it happen every hour, every 10 minutes, once every week, and then that's when backups will then happen. Anything you want to add in regards to that, Taylor?
So, we saw, like, if we go back to that schedule, I don't know if you saw that up, but we saw that, like, the full
You want the Wikipedia?
backups were on Sunday.
The Wikipedia article?
Yeah, if you could.
Yeah.
Because it had that nice schedule in there where it showed, like, oh, Sunday, you know, like the IT team or the cybersecurity team would come in and they're going to do that full backup on Sunday. Because depending on your guys' data set, like, that's going to be an all-day affair. And if that fails, like, you're pulling an all-nighter. There's differential and incremental backups. Those can just happen in the background. Your users wouldn't even know about it. It's not going to take the network, you know, all of its capacity. And it's going to be much, much smaller, hopefully, than the full deploy or the full backup, unless you're, you know, changed everything about your network and everything about the operating system.
Solid. All right, sweet. And then let's talk about logging. So by default, your Windows computer will be doing lots of different types of logging, and you can actually look at these logs. If you type in, event viewer, here we go. If you go to event viewer, you will see these logs. So we talk about the security application setup and system logs, and those are going to be available here if you open up Windows logs. All right, you'll see that you have the application, you have security, you have your system, and you have your setup. I don't know why I said that in a different order, but all those logs are going to be found and inside here. So this can be useful for several different ways. One is for auditing. So if you, cybersecurity purposes. So if you want to look and see who's been logging into your computer, who they've been logging in as, what time they've been logging in, all of that is logged by default on your computer, and you can find those logs here. So if you're suspicious that someone is logging on your computer when you're not looking around, or you might think you've been hacked or something like that, you can look through things like the security log to see exactly what's going on. You can see if people have been using admin privs. So for example, like when you get that box that pops up and it asks you if you want to continue as like admin, those will be logged in here too. There are several different application logs that are in here. So this will be in regards to various different pieces of software that you have. So you can see some Docker logs in here. Not all of them will be super detailed, but they do vary on their level. So there is information, warning, error, and critical, I believe, for the levels of a log that a log can be. Can I see if it should be in filters, right? Here we go. Filter. So there's 4 main ones that you'll see, and then there is also verbose. We're not going to be quizzing you guys on any of the different event levels. It's just that you understand that there are logs here. And Taylor, anything you want to add before I continue?
Nothing really specific here. Just going over the log types. Once again, so this is important for both like cybersecurity awareness. You know, if something happens, you can go find it. If you think something happened, or if you know something happened, you come in here. let's say you see the admin event of them modifying files in a directory. You can then like walk back what they did, try to see like what they stole or undo what they damaged. But the other side of this, as a software developer, is let's say we're running a complex application, and we're pretty confident it's doing one thing, but we come over here to the logs and we see that it's just not. Or it's just being hemmed up by Windows telling it that it can't do it. This helps save you hundreds of hours of smashing your face into the keyboard because it just tells you that it's got blocked.
And you as a dev, you don't have to log to this, but you can set up compatibility to log into this. So post launch of your product, your logs would go into here. So that way individuals that are utilizing it can then look at these logs if needed to find important information out. So specifically, your security log is going to be everything in regards to the security of your system, including things like when users log in and log off. All right. And on top of that, attempts to log in. So if people are trying to continuously log into the computer and they fail, those will all be logged into the security section. Your application log is going to be reserved for third-party applications. All right, so again, if you make an app and then deploy it out, people are downloading and installing it, you can log here and people will like it if you do, because then they can add it to items that they can audit when maybe something's gone awry or they're trying to figure out an issue with, I don't know, their system in general. I don't know, there's like a million different uses for this. Your setup log is going to be everything that happens during your Windows setup. So Windows being turned on. Is there any other reason why setup would be used, Taylor, that you know?
Not off the top of my head. It's not stuff I interact with too much.
And then your system log is going to be reserved for the operating system itself. So your operating system itself will be throwing logs into here in regards to all of the stuff in regards to the operating system. So just your operating system right here. And that's pretty much all you guys need to know. Just the high level application for third-party applications. Security for the security operating system. Setup for Windows on setup. System reserved for the operating system to log information. That's it. We're trying to fill in a lot of the blanks for you guys on a lot of these concepts and give a better like holistic view. But at the end of the day, a lot of the exam for these items in particular are going to be more so like terms and definitions. So you'll get either a term and then need to match up the definition, or you'll be given a definition and then need to match up the term. All right, that's pretty much the goal of what we had for covering today. Are there any questions before we move, or before we call it a day? So as a quick review rundown, these are the different types of accounts you can have on Windows. All right, these are the default built-in accounts. This is where your accounts are going to be stored only in regards to local. All right, this is only in regards to local. All right, local accounts. This is where your accounts are going to be stored if it's a domain account. This is going to be for everything in regards to organizations that's not authentication, so file storage, etc. These are going to be in regards to who can do what and where, so all about permissions. This is just the basic layout of your Windows operating system when it is first installed. So you'll have the users program, the two different types of program files, the Windows folder, and that last folder, the perf logs, but we don't care too much about those ones, at least right now at this level. When you look at files, they have attributes and properties attached to them that you can then alter by viewing the settings and files, viewing the settings and settings file permissions. All right. Windows uses discretionary access controls, and their drives are formatted using NTFS to be able to handle discretionary access controls. And you can view this when you look at the permissions of a file. And you do that again by just right-clicking at files or folders and looking at the properties. And then if you go to security, this is where you can alter those permissions and individuals that can access it. There are several different types of backups that you can perform in Windows, but this isn't just limited to Windows. This is pretty much extends to all types of different software and operating systems. And then Windows will have 4 main logs that you need to be aware of: your security, application, and setup. And security, again, is going to be the security of your computer. Application is third party. Setup is going to be for your computer turning on, and system is going to be specifically for your operating systems. So that's pretty much the high level overview and pretty close to what you'd be quizzed on the exam. Anything you want to add in there, Taylor?
No, it's a pretty, so this is a pretty comprehensive look at like Windows fundamentals. 90% of this is not needed to be a dev. But the more things that you know, the better off we are. And when we start getting into, like tomorrow we kind of get a preview of that, we're getting into Windows Command Prompt and PowerShell. These concepts are going to come into play a lot with those things. It's like when we start using a shell, we no longer get that pretty GUI where we can right click. You have to know the names of what you're looking for. So these things will come into play tomorrow, so don't data dump it all.
Yeah, we include this part particularly because Windows is growing in the server section of cloud computing, specifically the Windows operating system. So it's been historically the default to use Linux systems in a lot of cases to run your applications, but Windows is pushing hard with their Azure cloud. They're dumping lots of money into .NET, and there is a rise coming right now of and a wave coming of people that are adopting widely .NET, especially because of their recent update Maui, which allows for write once, work everywhere. So you can basically write an app and in C# or whatever supports .NET, and then deploy it on Windows, Linux, even web, mobile devices. So it's good to know this because we don't know where you're going to be developing as a developer. You may be working on Windows machines or Linux machines or both. So you need to know at least the basics. All right. If there are no other questions right now, I think we'll call that one a day. Tomorrow we're going to talk about DOS, the PowerShell command prompt, and we're going to learn about the DOS commands that are pre-built into your computer, even though your computer isn't DOS. They're just legacy commands. And that would be, I think that will be the goal for tomorrow. It should be not too long of a day tomorrow, and then we'll be jumping into Unix. All right. I think that's about it. So I shall see you guys on the next one.
Later.